Wilfred something Pythagoras, whatever his name is. He is a philosopher in ancient Greece who lived in the 6th century BC. He studied astronomy, mathematics, music, and religion, but he's most well known for his famous theorem. Okay, and that's the one we're going to learn about. The ancient Babylonians, 1,000 years before Pythagoras' time, and the Egyptians also knew that there was a relationship between the sides of a right-angled triangle. Pythagoras was the first to clearly explain and prove the theorem using mathematical symbols. So Pythagoras' theorem only works, and you might want to underline that, on right-angled triangles. Only. Okay, only right-angled triangles. These are triangles that have a 90-degree angle, and you will usually see the little right angle like that drawn in your diagram. The longest side, and I have no idea why he chose this name, but he gave a special name to the longest side of the triangle, which is called the hypotenuse. Lovely word. Okay? The other two sides are sometimes called the legs, but we will be using the letters A and B to represent them. So on these little diagrams here, it says in these triangles we want to name the following sides. We want to call the hypotenuse a H and the two shorter sides the A and the B. Now I personally think it's easiest to start with the hypotenuse. What you do is you find your right angle, here it is, and the side straight across from it is always the hypotenuse. So we put the H there. The two shorter sides are the ones that are on either side of that right angle. One of them is going to be A and one of them is going to be B. It actually doesn't matter which one is which. If you label them the other way around, yes, write this on. If you label the other way around, it is still correct. The hypotenuse, though, has to be that one across from the right angle. So let's practice that again. Right angle is here, so straight across. That one is going to be the hypotenuse.
Do we draw the arrow?
No. That's just so you can see what I'm doing. You don't need to draw that arrow. The A and the B, the two shorter ones, you can switch them around if you want to. One's A, one's B. Okay, have a try of 3 and 4. See if you can do them. Label the hypotenuse and the A and the B.
What's the significance of the hypotenuse?
Well, we need to be able to identify them so that we can use the formula I'm about to show you. Okay, so you should have your H's in the same place as mine, but if your A and B is switched in a different order, that is still okay.
So you don't have to write a line?
You don't need to draw the arrow. That was just to help you see where it is. So, discovering Pythagoras' theorem. If you use, have you guys got your rulers there?
No.
Well, okay, for those of you that do, you'll be able to help us out. The rest of us, we can use the grid for some of it. That green square, how long, in counting the spaces there, how many spaces is the length of that square? 4. Good job, Julia. 4. How long is the orange square?
4.
It's 3 spaces. And now the blue one is the one you'll need your ruler for. How long is it? 5. It is 5. Good. Now this is not a question that we're trying to answer. This is actually discovering what Pythagoras discovered. This is discovering our rule. So what he discovered was that green square. Do you remember how to find the area of a square? If it's 4 long, you do 4 times 4. So the area of that square would be 16. The area, so I'm going to put A for area of that, is equal to 16. The orange square, if I do 3 times 3, the area of that would be 9. And the blue one, 5 times 5, is 25. And what he noticed is by squaring each of those side lengths, what happens when you add 9 plus 16?
25.
You get the 25. And it doesn't just work for the 3, 4, 5 side lengths. It works for any side length in a right angle triangle. If you square the two shorter sides, here it is down here. Oh, there's Homer. There was an episode on The Simpsons where Homer was intelligent for one whole episode because he could do Pythagoras' theorem. But anyway. Okay, so this is the formula. Remember the A and the B are the two shorter sides. We squared them. That's what we will find in the area of the squares there. We did A squared and we did B squared. And when we added those two measurements together, we found out what the longer one squared was. And that's Pythagoras' theorem's rule. The hypotenuse squared is equal to A squared plus B squared. Now, some teachers, some schools only ever use that formula. The trouble with that formula is that you want to get a H or an A or a B all by itself. You don't want to have those squares in there all the time. So to make things easier, we can actually rearrange that formula. On the next page, here it is here. Actually, I'll show you first. We just did this. We just did this in equations. If I wanted to get rid of the squared on that hypotenuse, remember what the opposite of a squared is? To square root. So we put a square root sign over the A squared plus B squared. Now we had a plus or minus at the front of that. You remember that, don't you? The plus or minuses. But the reason I don't have the minus for this is because we're talking about a length of a triangle side, and you can't have negative lengths. So even though equation solving, yes, you could have plus and minus signs, when it comes to a practical situation and I'm trying to find the length of the side of a triangle, I can't have a negative, so we don't do the plus minus bit, okay? So that is the formula that we are going to use. Anytime that you want to find the hypotenuse of a triangle, a right angle triangle, that's our formula. H equals the square root of A squared plus B squared. So this is what you have to do. Here's our examples. Find the longest side in each of the following right angle triangles. Now, there are going to be a lot of formulas to learn. So I want you to start from the very beginning. Every time you need to use a formula, write it down first. And that helps you start to memorize it. So the formula for everything we're doing today is this one. H equals square root of A squared plus B squared. The H is this hypotenuse here that I'm trying to find. The H in my diagram. Remember the A and the B? That is the two shorter sides. I'm going to call that one the A and that one the B. Putting them on my diagram. Now we're going to substitute those numbers into my formula. Now, if you put your equal signs underneath each other, you don't have to keep writing H. Okay, because that's just H equal to all of the things that I'm going to write underneath there. Big square root sign. A is 6, so 6 squared plus, and the B is 8, 8 squared. Okay, so there should be 3 lines. Formula, substitution, which is what I've just done, and the last line is to do to calculate it. So you get your calculator out, big square root, 6 squared plus, you all know where your squared button is?
Yeah.
8 squared. Squared button is just there.
Doesn't seem too hard.
Okay, so I typed that in, I pressed equals, and that equaled 10. Now that is the length of this hypotenuse here, and I need some units. Centimeters, okay? The other ones are in centimeters, so that one's going to be in centimeters. And that's it. That's what we're doing. That's Pythagoras' theorem. Easy, right? Let's do it again. Not much. Question 2. Let's do it again. We're finding the hypotenuse, the H. So we write our formula down. H equals big square root of A squared plus B squared. Okay, I'm going to call the A the 12 and the B the 9. So second line is to sub those numbers into the formula. So square root sign again. A is 12 squared and B is going to be 9. So 9 squared. Third line is type it in the calculator. Square root 12 squared plus 9 squared equals 15. 15 what? Meters. Yes, don't forget the units. Good job. Not all of them work out to be nice whole numbers, but so far we've got some nice ones there. Let's try question 3. finding the hypotenuse. We've got a little h there, finding that hypotenuse. So h equals square root a squared plus b squared. A and B, I'm going to call A 6 and B the 2.5. Let's sub it in. Second line. Square root. A is going to be 6, so 6 squared, plus B is 2.5, so 2.5 squared. Am I going too fast? Is this, yeah, everyone's following along well? Good. Calculator. 6 squared under the square root sign plus 2.5 squared equals 6.5 millimeters. Great. Okay, that's it. We're doing lots of practice of that today. So your worksheet follows straight after, page 6.